Hello everyone, welcome. Today I'm going to go over C++ modules. C++ modules started out in C++20. So before we begin, make sure you have set your compiler settings to compile with C++20. For Visual Studios, over here, just go to your project, properties, and make sure you have set C++ language standard to C++20. Okay, so first off, let's make a C++ module file. Going to hit Control-Shift-A and select Module Interface. I'm going to give this one a name, mylib, and enter. Okay, let's start out with the basics of what a C++ module file has. At the top here, you can see the keyword export and module. These keywords denote that this file is a module file and that this mylib here is the name of my module. I'm going to go ahead and just erase this. There are a few other ways you can declare your module interface. You can also declare it with a export module, let's say mylib, and then colon. This makes it a partition, and I'm just going to say A for now. We'll go over partitions in just a bit. Then you can also declare them like export module mylib dot A. So the first one here is a primary module interface. This one here is a partition to a primary module interface. So, and this one here, well, it's actually just basically a primary module interface. But the dot and the colon carry different meanings. This here means that it's going to be a partition, which is part of a module. It's like a module unit. The dot here is for basically your own use. If you've ever used something like C#, you've noticed how the dots appear in the order of your file format. So here it's just up to you as the user. Maybe you want to organize things a little nicer with names. Then finally, there is the global module fragment. This is declared only above your primary module interface declaration right here. So we're going to get rid of these just to avoid confusion. But you only have one of these in your file. And this has to be at the top of your file unless you want a global module fragment. In here is where you include stuff with your preprocessor and all that, definitions, let's say IO stream here. All these preprocessor directives have to be put here. Okay, so let's talk about how you can make things visible to the user. Modules are great because they actually let you control what is visible. So unlike a header file where everything that's just declared in the header becomes visible, here you get to control what becomes visible by the keyword export. So let's go ahead and just make some function names. Let's say hello world. And you know what? Let's just show the difference. Okay, so because hello world has export next to it, it's going to be visible, and hello YouTube here will not be. So let's just test that out. Import mylib. Just to make sure I have that correct. Okay. Let's go ahead and build. Excellent. IntelliSense kind of breaks sometimes with modules, but you should build just fine without issue. Now, if I try hello YouTube, you'll see IntelliSense sees it for whatever reason, but it's going to give me an error saying the identifier is not found. That is because this is not visible to the user. This was not exported. So to just fix that, just make sure you put export. There you go. Okay. This goes the same for anything like classes. So class person, right? If I want to export, make class person visible, export. If I want a whole block of stuff exported, let's say I have a namespace, and let's just go ahead and, you know what, let's put all this into that namespace. So now, what I could do is I could just get rid of all these exports here, and anything in the block of this namespace block of my lib is now reachable to the user. So let's see here. Might have missed something just, oh, duh. That is not correct. Let's fix that. Okay, great. So it compiles, it won't run it right now. But ultimately what you see here is export is needed because modules require you to be explicit, kind of like a class, right? You need the public keyword to make things visible, and anything else inside the class outside of that public line is not visible, right? Because this is essentially private by default. So it works the same way. I could have namespace mylib, and I could have void hidden. Whoops. Right? And that's it. Well, let's go ahead and actually make that compilable though. So stuff inside here would not be visible to the user. It's just a great way to control what's exposed to the user or the importer. Moving forward, let's go ahead and talk a bit more about how you can keep a partition, or I'm sorry, what is known as the module partition. I showed that off earlier. I showed you, actually, before we do that, let's go and talk about the module private module fragment, sorry. This section here basically comes at the end of your module. It declares to the compiler that this is the end segment of right here, your whole module file. A private module fragment now means that you are going to make your declarations, your implementations to your declarations. So let's say person here had a hello. Well, in order to make hello do something, I could implement it here. But let's say I want to keep it similar to my, think of it as like your CPP source, and up here is your like header source, or sorry, header file. So what I'm going to do here is make void mylib, and there we go. Now I have implemented the details to hello from person over in my private module fragment. It's just, hopefully will be something that can be used by compilers later to sort of know, hey, I only need to worry about this top part here. But more or less, it's also just another means of keeping that similar approach you probably are used to with CPP and header files being separate, one with declarations and the other with implementations. All right, so now let's go ahead and start with the last segment here on partitions that I wanted to touch upon. Now, partitions are going to require a colon at the end of a primary module fragment. So we're going to make our primary module fragment animal. Okay. And we're going to leave this blank for now. And then we're going to go here and we're going to make another one called cat. Okay, so cat is actually going to be a a partition to animal. So here I'm going to go ahead and add the animal in front of it and then colon. I need to have this declared somewhere else. This denotes that this is my partition, and this is the partition or module unit itself. Now, for this, I'm going to say export class cat. Let's go ahead and just create our great. So we made cat. We got to also include. And there we go. Cat is complete, ready to use cat, or are we? No, we're not. Because like I said, we have to be explicit. So one of the ways we can export cat to the users without having them, let's say this had several other animals, we can actually declare the export import declaration here. This means that I'm going to import something and then export it to the users because again, we have to be explicit. And now, because animal is the primary module unit interface, I actually only need to say cat, cat. Now let's just pretend I had other things here, like, let's say I had dog, right? Beetle or something, right? All these other ones, if I made them, I would add them here and they would be exported by this animal primary module interface. So now, if I go here, I import animal, and now I can just say cat, and my cat is made. Cat cannot be accessed. Oh, because of course I made private declarations again, public. There we go. Cat is an unreferenced local variable. True, I did not meow. There we go. And there we go. Now if I run it, you can see hello world YouTube, sorry, and meow from cat. So overall, primary module interfaces are what you declare like this, right? You have the export module, the name of your module interface, and you can go ahead and create your contents here below. Export is required to make it visible to the importer. An importer will not see anything unless you export it. And you can go ahead and make a primary module interface like this with partitions if you'd like, and then you can import those, or sorry, export those imports. You also can do the same here. Let's say that my lib just had some other, modules that I wanted to expose, whatever it may be. This would also work. And then anyone who imports my lib also gets my lib 2, 3, and 4 along with it. So don't think that this is only 2 partitions. You can also go ahead and just export other imports if you need them. That way maybe you only just need, hey, I'm using this module for my module and I want the user to be able to build with my module. So in order to use that module, I have other imports I need them to have exposed. You can do it like that as well. Final note is that module private, this module private spot, this primary module fragment, sorry, private module fragment is only something you can implement in the primary module interface. So just to demonstrate, let's say I had cat. Now, if I was to implement the details of cat, and I tried to build, it would give me an error saying that private module fragments can only appear in the primary module interface. That is because this is a partition. So what does that mean? Well, the primary module interface for this class is here. now, because I am importing cat here, before I export it, it's visible to this primary module interface. And I need to also include. There we go. In this case, I am importing because I cannot use includes here. I can, however, include here with the global module fragment, and this would also be visible to my primary module fragment. But some headers, some STD library, and especially STD libraries, are importable as well, and there's a difference with them. But for the most part, basically the way I work is, if it's a standard lib like this in your file, you could import them safely. That may not be the case with all header files, just so you know. But if you're unsure, just go the old-fashioned way that you're used to, right? IOStream, include, put it in the global module fragment above, and it's going to be exposed down here at the bottom. All right. So to recap, we have module declarations with export module. All keywords, all imports that are visible to the user have to have explicit export. Primary module, private module fragments can only be in the primary module interface, and these are where you put your declaration, or sorry, your implementations to your declarations. This is just, again, partitions are kind of these module units, as I call them, that build up a whole primary module interface. And then you import your modules like so that you can use them. This is similar to your include statements. Okay? Thank you very much for watching. I hope you learned something. And if you'd like anything else, if you'd like to learn anything else about C++ or C# or some programming basics and whatnot, please leave a comment below. If you enjoyed this video, leave any comments or questions, and I'll be sure to answer them if I can. And thank you again. Until next time, goodbye.